Hey everybody, Ethan here. Today I'm going to talk about platins, or platinum-based cancer therapies, or chemotherapies. And the reason why I'm talking about this today is the wickedness that is studying for step one. Really, studying for this has made me realize I am in such deep trouble that I decided to just sort of scan the topics or anything that caught my eye. And what really jumped off the page were these, platinum-based drugs. And I think, Ethan, he must know so much about these drugs. The answer is no. It jumped on the page not because of knowledge, but because of something much more dumb, which is my love, former and current, of the game Pokemon Platinum. When I was a kid, it was released September 2008. I still remember my dad getting me the game from GameStop. And instead of, playing outside or learning or I don't know, making friends, I figured I already had a friend, and their name was Turtwig. And believe me, I spent a lot of time with Turtwig because, listen, a lot of people talk about the hours that these great athletes like Kobe Bryant put in, like going to work at 5 a.m. in high school. And that's pretty impressive. But my response is that those are really rookie numbers. All right. Ask my mom. I was an early bird. I wake up at 4 anytime really to play Pokemon. I put in those hours, believe me. And that's probably why I was wearing inch-thick glasses in elementary school. But you know how it goes, right? No pain, no gain. I wanted to be the very best. There really is a price to be paid for that. Now to decide, there's 4 things I want to talk about today: the mechanism of action of these platinum drugs, some examples of these drugs, the indications for their use, and the toxicities you should be concerned about. Let's start with mechanism, all right? I'm going to focus really on cisplatin, which is the drug you see here. Cisplatin is taken up into cells via specific transporters and ATPases that I'm not going to sort of get into right now, or really ever in this video, I should say. Inside the cell now, cisplatin is in a low intracellular chloride environment, all right? And that low intracellular chloride means it's easier for water to displace these chlorides and sort of make chloride a good leaving group, right? Because there's not as high concentration outside of the cisplatin. It's in the cell, it's around this low chloride environment. It's much easier for hydrolysis to occur and chloride to be displaced. So hydrolysis occurs, hydration occurs, chloride is displaced, and I think I'm not an expert on this. Again, I may be wrong, but I think it can happen on this chloride too. Both chlorides get displaced by water. Hydrolysis can occur. And this really creates a sort of activated, hydrolyzed, aquated cisplatin product. And it's really a potent electrophile. And as such, it can bind with tons of stuff, most notably the nitrogen 7 or N7 reactive center on these purine DNA bases, including, of course, purines are A's or adenines and G's, guanines. And when it's able to bind with that, it's able to cross-link 2 strands, seen here with this cisplatin molecule cross-linking. This cisplatin molecule here is highlighted in green, cross-linking those 2 molecules from right to left. And really, this cross-link is DNA damage, right? When you link 2 DNA strands together, it stops the ability for strands to separate, meaning that basic processes like transcription and replication, which require the strands to separate, are impeded, and that thereby can precipitate apoptosis. What you will notice here in this explanation, or this very brief, abbreviated explanation of this mechanism, is that there's no cellular targeting specifically for cancerous or malignant cells. This theoretically could and actually does affect all or most cells. However, generally, the fastest proliferating cells are killed, which in theory are cancers. That makes sense, right? Because these fastest proliferating cells need to divide a lot, which means they need to do DNA replication a lot, which means that every time that they try to replicate and separate the strands, they can't, and more apoptosis is triggered. But again, even though these fastest proliferating cells, meaning usually cancer cells, are most targeted, that doesn't mean that they're always going to be the only things targeted. And we're going to talk about that in the toxicity section. I do, though, want to talk about right now about how drugs like cisplatin, these platinum drugs, differ from drugs like cyclophosphamide, seen here. The distinction between platinum drugs and the alkylating agents like cyclophosphamide, which do share a very similar mechanism, is a small difference. It's a technicality, really, that there's no alkyl group that you see like here in cyclophosphamide in a platinum drug. These platinum drugs, again, you saw that cisplatin, there's no alkyl group, unlike these alkylating agents like cyclophosphamide. But both of these drugs, platinum and alkylating agents, introduce these cross-links and thereby apoptosis. The only difference is, again, the alkyl group. Let's talk now about some examples. There's 3 big ones I want to talk about: cisplatin, which I already talked about already, the first-generation drug, then the second-generation carboplatin, and third-generation oxaliplatin. In terms of carboplatin, very similar mechanism to cisplatin. There's just less aquation or water attack, and that really helps to diminish toxicity. Oxaliplatin, seen here in the bottom, I should clarify. This is carboplatin. This right here is oxaliplatin. Oxaliplatin has this what's called this DACH ligand. It's a diamino ligand. You see there's two aminos here, diamino ligand. And this DACH ligand helps for increasing uptake. It's really more lipophilic, and it's also less reactive due to a different leaving group compared to just those chlorides that you see in cisplatin. So again, carboplatin, less equation, diminished toxicity, oxaliplatin, more lipophilic and more uptake, and also less reactivity and generally less toxicity too. Actually, I'm not sure about the toxicity part, but definitely less reactive due to different leaving group. I do want to talk about indications now. So these platinum drugs across the board are first-line treatments for malignant tumors. So it's a lot of cancers, but that's going to critically rule out hematologic malignancies like leukemia, for example, right? These are IV drugs that are administered over 6 to 8 hours and in one sitting. And these sittings or infusions usually occur once every 3 to 4 weeks. These are, pretty lengthy infusions that you get around every month or so. Cisplatin is FDA approved for ovarian, testicular, and bladder cancer, but it's often used off-label for other malignant tumors, including breast and colorectal cancer. Carboplatin is FDA approved for ovarian cancer, and it's used for more aggressive tumors because it's aforementioned, as I mentioned before, right? The lower toxicity allows you to do higher doses of carboplatin when compared to cisplatin. And it's often used also off-label, like cisplatin, for other tumors. Oxaliplatin is FDA approved for post-resection or metastatic colorectal cancer, also often used off-label. I'm not going to really talk about resistance, but unlike cisplatin and carboplatin, it's more resistant to resistance. I mean, it just, that's a terrible way of saying it. It's just doesn't form cross-resistance in the same way that cisplatin and carboplatin does, which is good. And because of that, it's often used in conjunction with drugs like cisplatin. So you can give cisplatin and oxaliplatin together. And because oxaliplatin doesn't have as much cross-resistance as cisplatin, it helps increase the efficacy of the regimen in its entirety. Let's now talk about toxicity, all right? The primary dose-limiting concern is nephrotoxicity, the kidneys. When you accumulate, or this is what happens. Generally, cisplatin accumulates in these proximal tubular cells in the kidneys that leads to DNA damage to these kidney cells, damage to cells themselves, of course, leading to acute kidney injury and or chronic kidney disease. And this is really important to understand just from a mechanistic perspective, because as I mentioned before, when I was just talking about the mechanism of action, there is no cellular targeting for these platinum drugs in terms of targeting a cancerous cell. So anywhere a platinum drug accumulates can be harmful to those cells because really, platinum drugs can affect a lot of cells, not just cancer cells, because they're just fundamentally toxic, right? They deliver non-specific DNA damage. The real mechanisms that these cancerous cells, because of their fast proliferation, are disproportionately affected. In terms of ototoxicity, the ear, number 2 there, the concern really is not just because of accumulation, but also because of this interesting nugget I do want to share. As I mentioned before, once cisplatin is aquated, meaning it gets activated, right, it becomes this potent electrophile, only 1% of this activated cisplatin actually cross-links DNA. The rest of cisplatin, especially once it's activated, can actually react to form reactive oxygen species, which obviously can damage things. And in this case, this is the purported mechanism for the ototoxicity that is associated with cisplatin. Right, and this is not good, right? Because we assume, and we do know that, these cisplatin forms these cross-links, but the fact is that this active cisplatin can do these other harmful things, including form ROSs, which then hurt the ear. You don't want to be worried about neurotoxicity too, because cisplatin can accumulate in the dorsal root ganglion and cause DNA damage and, of course, cellular damage there. Nearly all individuals who take platinum drugs experience some form of GI symptoms. It's thought to be CNS related, but it's not fully understood. And mild suppression is also a concern, especially for carboplatin. Remember, carboplatin, because of its lower nephrotoxicity, you're really going to be able to increase the dose, right? And that means that you're going to have a lot of carboplatin sitting around there that's going to really cross-link DNA and affect not just cancerous cells, but more so all quickly proliferating cells, including myeloid progenitors and these blood cells, which helps explain that's the mechanism for that basic idea for the mechanism of the mild suppression you see, especially when you use carboplatin in terms of other platinum drugs. But again, in general, platinum drugs affect rapidly dividing cells. So it makes sense why mild suppression is a concern when you're talking about the use of platinum drugs. So that's really all I've got. I do want to leave you with one last thing, though. These drugs are in the news, or at least the medical news, due to shortages. All right, these back orders for these drugs are not being filled, and unfortunately, doctors are being forced to deviate from standard of care, which usually involves these platins as a key component of these chemo regimens for malignant tumors. So again, this is an important topic, and it's increasingly important now in the context of this shortage. So that's all I've got for you today, except for the review. What did I talk about? 1, platinum drugs create DNA cross-links that cause apoptosis of cells, affecting rapidly dividing cells most. Of course, this means cancerous cells generally, but also can mean myeloid precursor cells, which cause, of course, explain the myelosuppression we talked about earlier. Main examples include cisplatin, carboplatin, oxaliplatin, but other drugs are in development. These drugs are indicated for the treatment of specific malignant tumors, but are used off-label for a wide variety of malignant tumors. And toxicities include nephrotoxicity, ototoxicity, and myelosuppression, among others. And this generally stems from the accumulation of platinum drugs in specific cells. And this accumulation is bad because these platinum drugs are not specifically targeted to damage cancerous cells, but can damage really a wide variety of cells due to their non-specific DNA cross-linking and damage. So this is officially all I've got for you today. Here are the sources I consulted. I hope this is at least somewhat useful and yeah, informative. I wish you all the best. Take care. Have a good one. Bye-bye.